Hello, my name is Jonas Wagner. In this video, I'm going to show you a new tool that I created called forensically. It allows you to discover hidden details and manipulations in digital images. The main menu is on top. From here you can open up files. The image is now processed in your browser. It is not uploaded to any cloud or server, so it remains private. But let's go back to the original image for now. It has been specifically crafted to show off all of the tools that there are in forensically. The first tool that I want to show you is the magnifier. It increases the size of pixels and magnifies their contrast. Like that. The controls are really simple. Magnification controls the zoom level. Lower level, less zoom. Higher level, more zoom. Auto contrast and auto contrast by channel control how much the contrast is increased within the window. So let's turn them off for a sec. No contrast enhancement, just auto contrast. You can see there's a little bit more, but still fairly limited. And if we enable auto contrast by channel, you really start to see all of the details. But on the flip side, the colors also go wonky, which is not so cool. Let's have a quick look at another image. This is a macro shot that I took recently. With the magnifier, we can see that there are little specks of dust hidden in this image in different places. It can be really hard to see with the naked eye, but the magnifier makes identifying them quite easy. With these specks of dust, you could actually match an image to specific camera and lens configuration, just like bullets can be matched to a gun with ballistic fingerprinting. The next tool that I want to show you is clone detection. I think it's the coolest feature in forensically. So let's just open it up. It takes a little while to process. What it does now is highlight regions that it thinks might have been copied across using the clone tool, copy paste, or something like that. As you can see, it's quite sure that the clouds over here and here have been copied. If we go back to the magnifier, we can see that's clearly true. Let's switch back to the clone detection. The clone detection algorithm has quite a few parameters that I would like to explain to you. Minimal similarity determines how similar two regions need to be considered clones. So if we decrease this, we should get more results. In general, if we increase it, we tend to get less. It's a parameter that's a bit fuzzy, so it can be worth to just play with it. It would be quite silly to say that two patches of blue sky are clones of one another, just because they look very similar. So the minimal detail parameter controls how much detail an area needs to be even considered for the clone detection. A little bit goes a long way, so the default value of 0.01 is actually quite good. You can see if we set it to 0, we get more crap. If we set it all the way to 10, the tool tells us that no more clones have been detected. You can double-click any slider to reset it to the original value. The cluster size determines how many blocks two regions need to share in common in order to be considered clones. Decreasing it can give you more results, but will also increase the noise. Whereas if you increase it, you get less results, but they tend to be quite strong. The block size determines how big the regions are that the algorithm looks at. You probably don't want to change this parameter. The maximal image size decides how big the image is that the clone search is ran on. Increasing it can lead to better results, but it also takes a lot longer to process. And there we have our results. The last option is for debugging. It allows us to see the blocks that the clone detection is using after they have been compressed and filtered. So if we now increase the minimal detail, we see more blocks get rejected and black. Whereas if we lower the minimal similarity, the image is getting more compressed. And actually in more blocks, there is no detail left, so they become entirely black as well. The clone detection tool can also detect much more subtle manipulations to images. Let me quickly demonstrate this with another shot. Here it clearly detects manipulations to the skin. Yet if you just look at the image, it's really hard to see with the naked eye. And even with the magnifier, we still have some trouble seeing exactly what has been copied. The next tool that I want to show you is the error level analysis. It allows you to spot artifacts that are created when a JPEG image is compressed multiple times in a row. This happens when it is edited, for instance. I usually start with the quality slider all the way to the right, and then work my way down to see if something interesting jumps out. So let's do this. So here we see that the UFO has become blue and sparkly. But if we go to the magnifier, we can clearly see that this blue sparkle is also in the original image. And because it's so noisy, JPEG is going to have a hard time compressing it. So this is to be expected. Let's see if we can find something more interesting. Still nothing. 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 And there we start to get something. Let's move it down just a little bit more. And it becomes even more clear. What you can see now is that the shadow shows this white noise pattern. So you can't see anywhere else. You also see some weird glowy stuff on these clouds. Now if we set the opacity to 0 to see the original image, there's lots of other shadowy regions very similar to this one. Yet none of them show this particular white halo. Also it goes away again if we change the quality level. So frankly, this is strange. This is a strange artifact that needs some explaining. And one explanation certainly is that the image has been manipulated. You can also see that there is these patterns on the clouds. If you set the opacity away again, these clouds here are in fact identical. So why does it show up on these clouds and not on the other ones? This actually strongly indicates that the clouds to the left are the ones that have been manipulated, whereas the ones on the right are the originals. Let's look at another example image. This is a simple photograph of a wall that I took. Again, we will start with the JPEG quality slider all the way to the right and work our way down. At first, nothing appears. Whoop, there was something. And at around 95% quality, we can see that there's something weird again. A halo starts to appear around the image. Let's run the clone detection on that. The image size is still at 1024, so it will take a little while. But it gives us a very strong signal. It thinks these two walls have been copied. And if you look at them, clearly they are. so something must have been hidden in this image. Let's switch back to the demo image so I can show you the remaining tools. The metadata tool shows you additional data that is sometimes stored in images. For instance, you can see that this image was taken with a Sony camera. We can also see that it has been edited with a software called Darktable in 2015, but it was actually originally taken in 2014. There's also information about how the image was exposed and all of the other camera settings stored in here. The data that you find varies a lot between different images. So for instance, Facebook will strip all of the metadata. So an image from Facebook won't show you anything anymore in here. Sometimes images even contain coordinates. In that case, we can use the geotext tool to actually look at them. It will show you this little map pointing out exactly where the image was taken. Well, at least according to the data stored within the image. That data can of course also be manipulated. You can also see the coordinates over here and links to OpenStreetMap, Google Maps, and similar images around Flickr. That can be actually handy to identify whether the location matches the image or not. Some cameras and software store a smaller version of the image within the image, enabling fast previews. These images can be seen with the thumbnail analysis tool. In this case, we've been really lucky, and the thumbnail actually still shows the original image before it has been manipulated. So it turns out this is just a random photo that I have taken while paragliding, and not evidence for a secret alien invasion. I hope you have enjoyed this tour of Forensically and have fun using it. See ya!